Hello everyone, I'm Yuan Hao. My final project is called Elephant Migration Corridor Planner. This is a web application that combines a cloud-based database with a route optimization models. Before I get to the program, I would like to share the story behind this project. In 2021, a herd of elephants caught the attention of the people around the world. This herd of Asian elephants starts from the Xishuangbanna Natural Reserve and migrate 500 kilometers all the way north to Kunming. The reason why this migration have received so many attention is partly due to the fact that Asian elephant migration is very rare, especially over such a long distance. Another reason is that this migration route passes through a large number of villages and cities, which cause a lot of conflict with human life. Despite the effort of the official agency to avoid the injury to the elephant herds, this elephant migration has caused a lot of economic loss. According to the study, there are many reasons for this migration. It could be the increase in the population of a herd, a shortage of food, or an increase in the temperature. But whatever the exact reason is, what we can be sure is that such long-distance migration will happen more frequently in the future. So I think it's necessary to plan an elephant migration corridor to avoid the conflict between the human settlements and elephant. That's what this program is trying to accomplish. Next, let me give you an introduction to this program. The first is the model framework. The model has 5 major components: data collecting, model building, data storage, map generating, and live interaction. In the data collection sections, I will collect various types of data related to elephant migration, including elevation, forest coverage, length of water source, and so on. And I use ArcGIS to integrate those data into standard integration data format. Then I use the Python to transform the obtained data into graphic format for net-route analysis. And then I can use Dijkastra algorithm to calculate the optimal migration route. The result of the calculation will be imported into the BigQuery in the form of data tables, together with organized base table. With the data warehouse, we can visualize the data through the Carto and present it to the public through the web pages. These are the raw data used for the project. And from the map, we can see that each of them is in different row formats, which makes it difficult to use. Therefore, in order to properly handle this data within the models, we process the original data into hexagon shape of equal size, making the data within each of grade comparable. After overlaying the data onto the grade, each hexagon now contains all the data we need. I also add a ID column for each hexagon as a unique identifier. Each hexagon has an area of 100 square miles. This is the abstract individual variables. The green polygon on the map is existing reserve elephant. This is the variable for whether this is a city or existing habitat. The next step is the design of algorithm. After creating the hexagons, how to represent the connection between each polygon? We first have to extract the center point of each hexagon, and then we need to establish a graphic table to record the connections and the distance between each polygon and its neighbors. The graphic table will exist in the form of list, including the distance and the identifier. Another question is, how do we simulate the decision-making process during the elephant migration? To quantitatively represent this choice in the models, we need to introduce new variables in addition to the distance. In this model, we introduce the cost variable to represent the energy expend and the resource gain by elephant moving from point A to point B. Adding in the simulation of the models, cost is composed of other variables through the weighted contribution. This is the formulation for the calculation. And after building the graphic table and assigning the weight, we can start using Dijkastra algorithm to model the optimal path from a given point to another given point. Dijkastra algorithm is a very common algorithm in network analysis. It simulates the optimal road from starting point A to all other points in the models based on the weights. During the calculation, the algorithm constructs an unweighted list to traverse each point. Whenever the model finds the optimal route, it records this route and removes the destination point from the list. Therefore, this algorithm can efficiently help us achieve the desired functionality. However, the traversal nature of algorithm also result in especially long computation process. Given that our data contain 1,600 points, each computation usually takes more than 20 minutes. So how should we reduce the total time? Here, I use the pairing to enhance the efficiency by eliminating unnecessary computation. In this model, I will calculate the straight line distance from the start point to the end point, and then consider only the point within the distance, slightly expanding the range to ensure that potential optimal paths are not overlooked. After a series of calculations, we can get the result, which is the ID of the optimal path. After obtaining the set of the path IDs, we can calculate the metrics such as the average forest areas and the average altitude of the optimal road. Once these data are imported into BigQuery, we can then display them on the website. This is the website I have set up. The website mainly have two functions, data exploration and optimal road demonstration. In the data exploration section, we can view detailed information about each plot, including their altitude and the area. There will also be a statistic chart to analyze each layer. By clicking on the migration road in the top right corners, we can navigate to the second part. Here, I have displayed three potential optimal migration routes. We can switch between layers to explore different migration routes. By clicking on this road, we can also see the specific data for the chosen roads. From the result, we can see how this road avoid cities and high altitude areas to reach the destination. If you would like to learn more about this project, you can also visit my GitHub page to find it. This is all for my project. Thank you, everyone.